Hi everyone, welcome back. Today we're solving separate squares. Now if you haven't solved separate squares 1, I recommend watching my video for that problem first because my solution for that problem has a very similar concept to my solution for this problem. So in this problem, we'll be given a 2D integer arrays squares, and in each item in the squares array, we will have an array consisting of x, y, and l. X and y are the coordinates, and l will be the length of the square. Now we want to find the minimum y coordinate such that the total area covered by the squares above the line equals the total area covered by squares below the line. And one note that we need to know is that the squares may overlap, and when they overlap, they should only be counted once. So if we look at this example, these do not count as 2 but only count as 1 in this overlapping area. So if you look at this example, this and this has the same area, so we draw the y coordinate right at y is equal to 1 and we return 1. And for this example, since overlapping squares are not counted extra times but only once, then we will just draw the line right here to split these two areas equally. So we also return 1 as our result. So now that we have seen some examples, let's get to how we can solve this problem. Now we can use the same formula as we did in separate squares 1, but I actually found a simpler formula, but in case if you want to do it this way, I'll explain it real quick. So let's say we have an area that is less than the total area divided by 2, and then as we move up the y coordinates, we find an area that is greater, then we will simplify it down to this to find the minimum height. So area would be length times width, and then the length would be the height at point B minus height at point A, and then times the width. And now we want to put height B on one side, so then the equation will look like this. And then if we multiply by 2 for the numerator and denominator, now the formula will look like this. And then you will just plug in all the variables and then you will find the height. But actually a simpler way is we can just find the total area divided by 2, so that would be the target, and that would be where we can set the y coordinate. Now if it's between two integers, then we can take the area that got it past the target, subtract by target, and divide by the width. So that would be the area divided by width, which would give us a length. That would be the length we go over by, and then take the height of the area that we just calculated and then subtract by this height, and then that will give us the y coordinate. So what we can do is we can create a default dictionary consisting of the y coordinates from the input values for the keys, and the values would be two types of tuple. One would start with +1, and that means we are adding with. If it starts with -1, then that means we are subtracting with. And for the second and third item, it will be the x coordinate and the x coordinate plus the length. So as we go up the graph, then we will add certain rectangles to the area, and as we move up, sometimes the width may shrink, so we will need to subtract. Now afterwards, we will sort the y coordinates into a list, and then we will iterate through the list to calculate the total area. And simultaneously, as we are adding the area one by one to find the total area, we will add all the separate areas into an array. Now we will iterate through the array of areas that we just made here, and we will calculate the area accordingly and add to the accumulated area. And as soon as the accumulated area is larger than half of the total area in the graph, which is the target that we are looking for, then we can plug in this formula to find out the minimum height that can draw a horizontal line to split the graph into two equal areas. So let's go over this example real quick. And by the way, if you happen to get lost, there's quite a lot of variables to keep track here. Maybe you can try looking at the coding section first and then come back to here to see if that will help. So we will have this default dictionary, which these are the y coordinates, and these means we are adding, and these means we are subtracting. And this is the x coordinate plus the length. Now this would be the x coordinate, and 1 plus 1 is 2, so that's why this is 2. Width would be the width that we calculate, height would be the height that we are at, and the area would be the area that we calculate. The current points would be able to keep track of all the points that we have so far at whichever height we're on, so that can tell us what width we need. And cache will accumulate all the areas that we have, so in the very end we can calculate which minimum height that we need. So first we start here, we add 0 and 2 for the current points. So now we know that the width is 2 and the height would be 1, because we calculate that by taking this and this. 1 minus 0 is 1, so 1 times 2, the area is 2. Now we will add that to cache. Now the cache will consist of the height, the width, and the third one would be the area. Move on to the next height. Now we will add this to current points. The height is still 1 because 2 minus 1 is 1, and the width is still 2. 1 times 2 2 is 2, so we add 2 to the area again, and we will add this to cache. So we are at height 2, the width is 2, and the area is 4. Now we don't need to iterate to the last element because it wouldn't have a height for it to subtract it to, so we can stop when we get to the second to last element. So now we know the total area is 4. Then we will look for the target, so divide by 2. 2 is the total target, and now we will iterate through this cache and add the area one by one. Now the first one, we see that the area is already half of the area that we have. It already meets the target, so we plug in the formula 1, which is the height, subtract by the area, which is 2, minus target, and then divide by the width, which is 2. So this is 0. 1 minus 0 is 1, so we return 1. And the time complexity would be O of n log n, because we will need to make sure this default dictionary is sorted, and it will take n log n time to sort that. And the space complexity would be O of n as well, because all of these arrays and this default dictionary can take up to O of n space. So now let's get to the coding part. So first we will set up the default dictionary. We'll call it points, and target will initially be 0. Now for x, y, l in squares, we will add these to points. So points of y will append 1, x, and x plus l. Now points of y plus l, so the upper end of the square, we will append -1, x, and x plus l, because that is when we will need to subtract the width. Now we will initialize current points to empty and set the area to 0, and then initialize the cache to 0 as well. Now we will sort the y coordinates into a list, so we'll call it height is equal to the sorted list of points.keys. Now we will iterate through heights. So for I in range, length of heights -1. The width, we will define an update function. So update of heights of I, area plus heights of I plus 1 minus heights of I. That will be like the length, and we will multiply that by the width. And finally, we will append the height, the width, and the area to cache. Now I'm going to go ahead and define the update function. So it will be define update of y. Now we will loop through the points of y in that default dictionary, and if the first element happens to equal to 1, then we will insert x and l into the current points, and I'll use the insert left method. Otherwise, we will remove x and l from current points if it is equal to -1. And now we'll calculate the width. So we will initialize width to 0, and we'll use a left pointer. Now for the left and right point in current points, if the left point in current points is greater than the left pointer, then we will just add by right minus left. We'll add the entire width, and then we will set right to the left pointer now. So left would be equal to r. Otherwise, if the current right pointer is greater than the left pointer, so r greater than left, then we will just add by r minus left to the width. And then we will also update the left pointer, and then we will return the width. So that's how we update the width. And now we're going to do the last part, which is after finding the area, we will look through each entry in cache, and if the area is greater than or equal to target, then we can plug in the formula. So it will be entry of 0 minus entry of 2 minus target divided by entry 1. And let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.